In this video, I'm going to show you how to set up your CNC scratching station. In the box, there's a tip holder along with a pack of tips. To take the scratching station out, you can remove the packaging and then grab the top of the bag and pull the entire bag out. Then simply unwrap the USB cable for the microphone and pull the scratching station out of the bag. Be careful not to bump the motion system or grab the motors. Next, I'm going to show you how to load a tip into the tip holder. With the brass bar inserted into the black holder, use a Phillips screwdriver to loosen the tension screw. After carefully picking a tip out of the case, insert the tip into the brass holder. Make sure not to insert the tip first. You want the back of the tip to go through the hole. This ensures that you don't damage the tip during insertion. Then use a small Phillips screwdriver to tighten the tension screw. This needs to be quite tight, but also make sure not to damage the screw. After getting the tip loaded into the brass bar, straighten the bar and tighten it with the small M4 socket head screw. Next, we'll load the tip holder onto the scratching station. With the camera sufficiently far away, you can fit the tip holder onto the aluminum extrusion. You want the tip to be about 5 millimeters away from the surface. And when doing that, you should move the Z stage all the way down, then get the tip about 5 millimeters off the surface. Next, we'll get the camera focused. The camera should be about 4 inches away from the table. Turn the ring lights on by turning the knobs, and then focus the camera on the end of the tip. The focusing screw is very sensitive, or very fine rather, so it takes quite a few turns. Here I'm tipping the holder a bit so that we can see the side of the tip. Right now it's obscured by the brass holding bar. Putting it at a slight angle won't affect the scratching, but allows us to see the tip better. And then you want to focus the camera on the tip, not on the table. First thing we're going to do is open Pronterface. This is the control software. After opening it, you need to set the COM port. Then the baud rate should be set 1152/200. Then open the settings panel. The only thing you need to change in the printer settings is the bed width. It should be set to 25/25/1 with an offset of -12.5, -12.5, and 0. Then go to the user interface, set the interface mode to compact instead of standard. Control mode should be set to standard, and disable display temperature graph. In the viewer, the only thing we need to change here is the extrusion width should be set to 0.01, and the layer height should be set to 0.01 as well. After that, go ahead and hit connect on the printer. You should see printer is now online, and press the home button. Now you should see the scratching station start moving to home. And of course, before you have to do any of this, you have to turn the machine on. Once the machine is homed, jog the stage over a bit, and then place your tape at the center of the build table. It might be useful to stick your hand on top of the tape to reduce its stickiness. This makes it easier to get samples off. Here I'm using double-sided Scotch tape. I haven't tried it, but I think double-sided Kapton tape might work a bit better. The Scotch tape is a bit too sticky. During placement, I accidentally introduced a wrinkle onto the tape, so I was replacing it to get rid of the wrinkle. Make sure when placing your sample that the thin film is facing up. Then gently press the sample onto the tape by using tweezers and touching the corners of the sample. Then you should jog the stage. And you want to get the tip roughly centered over the sample right now. And the jogging is done by clicking the arrow keys in Pronterface. And because the tip was a bit too high here, I moved the stage down. You could see the red arrow that popped up on screen. That shows you how when the Z stage is all the way down, there should be no gap. And the gap between the sample and the tip, the second arrow that showed up, again, that should be about 5 millimeters or so. It should be just high enough to maneuver the sample around without the tip hitting. And then here I'm just centering the sample under the tip. And raising the table up a bit just to get it closer. I'm not touching the sample yet. I'm just getting it closer. Now we're going to load a scratching file. So these are .g-code files. You can open up a file, you can see it on the preview there. Use the middle mouse to scroll and zoom in. Then with the camera feed up, jog the sample around. You can see using the jogging controls. And then once you think it's in a good spot, start the scratching. And as it's scratching, the tip is not touching the sample yet. Slowly lift the Z stage up by turning the Z stage screw in while looking at the camera feed. Once the tip makes contact with the sample, you'll see it start to scratch. That's when you know the Z stage is high enough. You really don't want much pressure on the tip. The tips are very fragile, and having excessive force will damage the tips. Next thing I'm doing here is I see the camera wasn't placed quite properly. It's hard to see the scratching right now. Ideally, the ring lights you can see here, they reflect off the sample, and so as it gets scratched, we see that reflection changing. This takes some fiddling around, but once it's in place, you shouldn't need to make any more adjustments. I'll include a picture at the very end of the video of what the camera looked like when I finally got it in the right spot. But this is quite a fiddly adjustment. Once it's finished the scratch, I'm running the scratch again. And this is because during the very beginning of the scratch, it wasn't touching the sample. And so running it again ensures that you scratch the first part. You can see on the screen in the bottom left the printing progress. And if you ever need to pause it, you can hit the pause button. But note, when you hit the pause button, there's quite a long delay between hitting pause and the machine actually pausing. This is because commands are sent to the scratching station, and hitting pause stops the sending, but the scratching station needs to finish executing those commands before it will actually stop. Just while this is scratching, I'll talk more about the user interface here. On the left side, you can see this wheel, this circle, and then there's this is the jogging control wheel. So there's these concentric rings, and the most inner ring is 0.01. So clicking on that ring in any direction will jog the XY stage 0.01 millimeters. And then there's a 1 millimeter, 10 millimeter, and 100 millimeter. This stage has a travel of 25 millimeters, so the 100 millimeter you should not use. After homing, when loading a sample, what I'll do is, when you power on the machine, the first thing you should do is press the home button. The gray one in the bottom left. This will home the XY at the same time. After homing, then I jog the X in the minus X direction about 10 millimeters or so. It'll be about center. So I just click the 10, and then after I click the 10, I click the 1 5 times. And then I load a sample and then get the stage roughly under the tip, and then I look at the camera feed and yeah, repeat the process which you've just seen. So we're almost done scratching this pattern, and it's about to finish. Once it's done, just unscrew the Z stage to lower the Z. Make sure the tip doesn't bump the surface again, and then yeah, you can see I just hit home Y, so that'll just bring the Y all the way out to you. Alternatively, you could just use the jog wheel to do that. And then you can remove your sample using some sharp tweezers. For maintenance, really the biggest thing is the belt tension on the motors. This shouldn't come loose too quickly, but perhaps every 6 months or so, you should check to make sure the belt tension seems about right. Here I am loosening the 4 screws that hold the motors on. After loosening the screws, the motor is free to move around. And the idea is that you just pull on the motor to tension the belt, and then once the belt is tight, you screw the motor back in. Other maintenance for the machine includes keeping it clean. You don't want dust settling on the bearings. This can affect the performance. You should also lubricate if you hear it squeaking. The lubrication is not terribly important, but if the motors, if you hear a squeaking sound coming from the motors, this is the lead screw that runs through the micrometer. Putting some oil on that would fix that. The type of oil to use, you want to use a thicker oil. A light machining oil is not good. You can get, it's called 3-in-1 at Walmart. That also works. Any bike chain lubricant would work. My personal favorite is an oil called Tenacious oil. It's used for bottom bracket bearings on bicycles. It's a really thick lubricating oil. It's great for low-moving parts like bearings, this lead screw, linear feed-throughs, etc. There you go, and the belt tension seems about right. And then just jog the motor around just to make sure it's moving smoothly. The last thing I want to show you is how to generate scratching patterns. So I've made a Python program that takes a text file and turns that into the G-code commands for the scratching station. So here I am showing you these text files. And after installing Python on your computer, you can open a Python editor. I'm just using IDLE, it's very simple. And then open up the expansion trace generator program. And I'm just opening up the files. And there's user parameters, and then the body of the program is below. You should really only change the user parameters unless you have some intention for changing the actual program. Up on the user parameters, you set the file name for the text file to read from. This is what generates each unique path or trajectory. And here's the body of the program. Again, this shouldn't really be messed with. and I'm going to generate a G-code file here just to demonstrate it. You can see there I'm showing you that the files to run are G-code files, whereas the files to read from are text files. So this is what a text file looks like. These are just each point to go to. So the first two numbers are the XY coordinates, and then the next two numbers, negative indicates expand the X in the negative direction, positive one means expand the Y in the positive direction. So I'm just going to run this program and get an error because my file name is wrong and I didn't realize this at the time. So the unvalidated patterns folder is full of patterns that other people have made, but the expansion trace directions are wrong, and I don't guarantee that they work. If you would like one made at a certain size, let me know, I can make one for you. But I'm going to do the demo with one that I know works, or one that I have made to work. So there I am typing the name of the text file, but you don't need the .txt. And then just opening up ideally again. And now when we run this, you'll see the coordinates are printed out on the terminal. This is just to confirm that it's reading the file correctly. And then it will have generated this G-code file in the same directory. Pronterface uses the G-code files. And just to go back to the program again, the things that you may want to change, there's, obviously the file path, that's the name of your text file. The number of expansion traces, that'll linearly affect how long it takes to run the program. Trace step over, this is basically going to be your tip diameter, a little bit less than your tip diameter. I'd recommend in the future using maybe a 5 or 6 micron tip diameter. 3 is just a bit too small. And then the feed rate. I wouldn't change that from 40. If you go faster than 40, you risk the motor skipping steps. So going slower makes it more reliable. Let me know if you have any questions, and thank you.